Look up at the night sky, every star, every planet, every galaxy. It all seems so real, so tangible. But what if I told you that everything we can see, everything we've ever observed, makes up less than 15% of all the matter in the universe? The vast majority, over 85%, is something else entirely. It's invisible, mysterious, and it holds the cosmos together. This is the story of dark matter. So what exactly is dark matter? Put simply, it is a type of matter that doesn't interact with light or any other form of electromagnetic radiation. That means it doesn't emit light, it doesn't absorb it, and it doesn't reflect it. It's completely transparent, which is why we can't see it with any telescope. So how did scientists even discover something that's invisible? Well, it all started with some strange observations about how galaxies behave. Imagine a spinning merry-go-round. The kids on the outside have to hold on tighter than the ones in the middle, right? Gravity works a bit like that. In a galaxy, you'd expect stars closer to the center, where most of the visible mass is, to move faster than the stars on the outer edges. But when astronomers measured them, they found something shocking. The stars on the edge were moving just as fast, if not faster, than the stars near the center. According to our understanding of gravity, these outer stars should have been flung off into deep space long ago. The only explanation is that there's a massive, invisible halo of matter surrounding the galaxy, providing the extra gravitational pull needed to hold everything together. This invisible stuff is what we call dark matter. It's like the universe has a hidden skeleton unseen, but absolutely essential for giving it structure. Even though we can't see dark matter directly, we can see its powerful influence on the universe. One of the most compelling pieces of evidence is a phenomenon called gravitational lensing. According to Einstein's theory of general relativity, massive objects bend the fabric of space-time. When light from a distant galaxy passes by a massive object, like a galaxy cluster, its path is bent, just like light passing through a lens. What is amazing is that astronomers observe this bending effect in places where there isn't nearly enough visible matter to account for it. The light is being warped and magnified by a huge concentration of invisible mass dark matter. This effect allows us to literally map out where dark matter is located in the cosmos. Another huge clue comes from the structure of the universe itself. When we run computer simulations of how the universe evolved after the Big Bang, we run into a problem. If we only include the ordinary matter that we can see, galaxies and galaxy clusters just don't form the way they have. The simulations only match the universe we observe today. When we add in a huge amount of cold, slow-moving dark matter. It acts as a kind of cosmic scaffolding, a gravitational framework that attracted ordinary matter and allowed it to clump together to form the first stars and galaxies. Without dark matter, the beautiful cosmic web of galaxies we see simply wouldn't exist. This all leads to the big $100 billion question: what is dark matter made of? The honest answer is we don't know for sure, but scientists have some very interesting ideas. One of the leading candidates is a hypothetical particle called a WIMP, which stands for Weakly Interacting Massive Particle. These particles would be heavy, but they would only interact through the weak nuclear force and gravity, making them incredibly difficult to detect. Another possibility is a much lighter particle called an axion. Originally proposed to solve a different problem in particle physics, axions could also be the perfect candidate for dark matter. There are other ideas too, like sterile neutrinos, which are hypothetical cousins of the neutrinos we already know about. To find these elusive particles, scientists have built some of the most sensitive experiments ever conceived. They've gone deep underground into old mines to shield their detectors from cosmic rays, hoping to catch the rare instance of a dark matter particle bumping into an atomic nucleus. They are also using giant particle accelerators like the Large Hadron Collider at CERN to try and create dark matter particles by smashing protons together at nearly the speed of light. So far, the mystery remains unsolved, but each experiment rules out some possibilities and brings us closer to the truth. So why should we care about this invisible stuff? Because dark matter isn't just some weird scientific footnote. It is fundamentally important to our existence. It accounts for about 27% of the total mass energy content of the universe, while ordinary matter, everything we know and are made of, is just under 5%. The rest, about 68%, is an even more mysterious force called dark energy, which is causing the expansion of the universe to accelerate. Understanding dark matter is the first step toward a complete picture of our universe. It's the key to figuring out how galaxies formed, how they evolve, and what the ultimate fate of the cosmos will be. Cracking the dark matter code could revolutionize physics and change our understanding of reality itself. The search for dark matter is one of the most exciting frontiers in all of science. Powerful new telescopes, like the James Webb Space Telescope and the upcoming Nancy Grace Roman Space Telescope, are peering deeper into the universe, studying gravitational lensing and the evolution of galaxies with unprecedented detail. On Earth, next-generation underground detectors with even greater sensitivity are being built to continue the direct search for dark matter particles. And with upgrades to particle accelerators, we're pushing the energy frontier further than ever before. It's a global effort, a thrilling hunt for the invisible substance that shapes our universe. Every new piece of data, every null result, gets us one step closer to solving one of the greatest mysteries of all time. Dark matter may be invisible, but its impact is everywhere. It's the silent architect of the cosmos, the gravitational glue holding galaxies together, and a profound reminder of how much we still have to learn. The universe is far stranger, grander, and more magnificent than we ever imagined. The clues are out there, waiting to be found, and who knows, the next breakthrough that changes everything could be just around the corner. If you enjoyed this journey into the unseen universe, don't forget to like this video, subscribe to the channel, and hit that notification bell so you won't miss our next exploration into the cosmos. Thanks for watching.